Hello, everyone. So yeah, there are still some seats left if you want to be more comfy. I don't want to bore you though, because we are going to talk about why every chip counts and how this essentially drives the cloud rebellion. Now, let's quickly take a step back and kind of look at this statement of the terminology of cloud, right? In the end, cloud is just kind of this thing that describes essentially someone else's computer. If it's someone else's computer, in the end, provided by a company, like the big ones, Google Cloud, Amazon, AWS, right? But in the end, you're utilizing hardware from a data center that is provided by someone else. Now, obviously, a lot of ease of use goes into kind of the cloud ethos, right? You don't have to build up this infrastructure by yourself. If you're an enterprise, you can utilize tools that are existing and you can easily deploy and scale up with the resources that are being provided by someone else. So, all very good. Now, the only problem is that when looking at these cloud providers, we have kind of the big five, essentially, that dominate 67% of the cloud market and have kind of the monopoly, right? So this is also then going towards they can dictate the prices that you're paying for the compute. But they essentially also have then access to the data that you're using for your applications that you're deploying on them. And now here, as a private citizen, you might be saying, yeah, I don't really have anything to hide, so why do I care, right? This might have been true for quite a long time. Having kind of surveillance on an individual person was very expensive in terms of compute that you needed to use. But in recent years, with kind of the advancement of AI, this has drastically changed. Now, everything becomes quite easy to kind of look into different data points for one person and aggregate them by leveraging kind of the advancements in AI. So maybe this is becoming also a personal thing that you need to consider. But, I mean, definitely if you're an enterprise, this is another aspect in it. Then, on the other hand, I mean, you definitely have a lot of concentration when it comes to the server centers and also the servers that are being provided. Because Google not only has servers that everything of the servers in the data centers they own, they use subcontractors for this, for example. And, I mean, censorship resistance, if you look on top there, 4 out of these 5 companies are US-based companies. US-based companies have this nice little thing that they need to adhere to called the Patriot Act, which also means that in turn the US government might or might not have access, or at least has the capability to access the data that is running on this infrastructure. So another thing that then also comes out of this now in kind of the AI age is quite interesting if you think about utilizing centralized players that need to adhere to certain kind of aspects of it. They are also heavily opinionated when it comes to things that you're essentially running on them. In the end, probably not giving you kind of the service that you need or want. Talking about kind of the other's people computer, essentially, here on the left we have a nice little notification by one of the providers that I'm not naming here, but it's written there, that you're getting these notifications by saying, hey, there has been a new sub-provider joining our network because you're using the Google Cloud resources. And fun fact, on the right side, you see a list that is scrolling through. There are 400 or even 500 of these sub-providers. And all of these sub-providers, they have access to the servers and in turn the data that you're utilizing for your deployments. And I mean, just kind of putting this into perspective, where we are at this point, right? Having a really seamless way on how to deploy applications, having a very good developer experience, but in the end, we are sacrificing a lot in that aspect, and we can do a deep dive in all of this topic that takes us hours to go through, but I mean, losing the data ownership, not having privacy, and kind of having even nation state interfering with this data and with these applications that you're running on top of this infrastructure. And this is something that might sound a bit cyberpunky, might sound a bit kind of doomsday-ish, I don't know. But in the end, it's the current status quo, right? And we said, let's look at how we can actually address this and what effectively do we need to really build a solution that is kind of this global reaching, decentralized network of compute that has kind of the open source and open kind of community-based principles at heart, right? What do we need for that? Are we going the route of, hey, we can buy some servers, we can put a data center up in the US, we can put up one in Europe and one in Australia, and then we're decentralized? I mean, not really, right? So how can we compete against the Google Clouds, the Amazon AWSs? By leveraging the same hardware as they do? Probably not, right? They have the economy of scale at their hand. They can pull up data centers and bring in subcontractors that we have seen at scale that, I mean, no one of us really has the capacity to do. So what can we do, and what for other hardware is out there? Now here, just a little comparison. There are yearly 13 million servers being shipped for all of these data centers. But there's another kind of hardware type in the game that is kind of the champion that everyone carries in their pocket day by day, and it's the smartphone. Now, why mobile devices? A lot of people actually do not realize the compute power that these devices pack and the amount of kind of energy that they use for the compute that they're providing. And kind of leveraging these advantages means that we can compare like server prices with phone prices because they get the same compute in the end. And they have a few things on top of that, right? They have a secure enclave that not every server has built in the architecture of the chip. So we can suddenly do confidential compute. We can use iOS and Android devices. We can use devices that have a broken screen. All of us, I mean, upgrade our phones from time to time. Some of them yearly, some of us maybe every few years. And often the old device kind of vanishes in a drawer to be never seen again. Maybe we're moving and then we're like, okay, good. I don't know, maybe I should get rid of them, right? But what they are still is, they still are valid compute units. Even if the device has a broken screen, it's not usable anymore for me to use as a daily driver, and I need to spend a lot of money to kind of fix it, but it's still valid compute that is just sitting there. Valid compute that is more energy efficient than servers, that has additional properties already built in. And then there's also the phone that you're carrying around in your pocket, that you're using for notification, TikTok, social media, or other things. But you're never utilizing the full compute, essentially, that these powerful devices pack. So we can also use these devices. And in the end, this is how it looks. Nice. Thanks. So people all across the world providing upcycled devices that have broken screens, some of them one or two, some of them just their everyday phone, some of them take it to the extreme and have multiple hundred phones, essentially. But with this, all across the globe, we can build up this heterogeneous network of different devices, Android, soon to be iOS as well, and have really the compute power of these devices being utilized for the other side of the picture. And the other side of the picture is, like in the normal cloud, it's developers deploying applications on top of that. Here we have a little video of one person kind of bringing this to the extreme. And the interesting thing here really is, these devices, when they come to compute, they have 8-core, you can also see the damaged screens there. They have 8-core CPUs. They have 32 gigabyte of RAMs. You can build a little cluster here that rivals, for example, GPUs like the H100 from NVIDIA that cost $40,000. You can build this cluster of like 10 or 20 devices that have the equal compute for a few $1,000s. So this is kind of really turning everything on its head, utilizing these powerful compute resources, also running these devices are use way less energy than any server out there because they're optimized for this, right? You have your phone in your pocket, it's powered on, hopefully the whole day if you're not using it extensively, but we can leverage this as well. And we can leverage this for very interesting use cases. We can leverage them for any Web 2 application. We can leverage them for on-chain powered apps, but we can leverage them for decentralized confidential AI. And what is very cool about this and excites me and the team personally as well is the confidential aspect in AI. Because these devices are built with a secure hardware enclave in them that has a trusted execution environment, we can really get confidential compute. And what this means is that we can run AI models on these devices without the owner of the device being able to inspect what's going on the compute side. And this is the blocker for many, many enterprises, essentially using AI, right? The conversations that we are having is with a lot of small to medium-sized enterprises. We want to use AI, but we need to go back to the status quo before the cloud because we need to build up our own server centers again because we want to keep the data that is like business critical. We need to keep it internal. It's like for our survival, it's essential, right? It's kind of a must. We cannot utilize anything else. So here, we can utilize these advantages. We can provide the service with these mobile phones across the globe and run confidential AI models on top of them. And I think this is really the game changer besides deploying applications that are more affordable than others. Now, the only thing that you need to do is become part of the cloud rebellion, take out your devices and join us. If you have some devices in your drawer, take them out and join Acurast. Thanks, everyone.